What's going on, everybody, and welcome to our last project together. This project involves linear regression here, and just like most of our projects, it has a part A and it's got a part B. The part A involves creating that portion of your spreadsheet that's going to be able to perform the operations. Part B is where you actually use it. So fortunately, this one is going to be very, very short. So this is good, considering I know that we're nearing the end of the semester, and no doubt you're getting a little weary of stuff. But this is going to be pretty cool here. I know some of you have done linear regressions before in some of your algebra classes. It's really just the process of where you had to draw a line through data in a way of really describing upward or downward trends that were really statistical associations here. You're going to be able to figure out how to make it so that you can do that yourself from here on out. So let's actually start this and actually work this as quickly as possible here. You're going to find that this actually goes very quickly here. This one will not take long at all here. So let's first of all create our last spreadsheet on this project here, on this statistical spreadsheet here. We're going to add a sheet, move it farthest to the right here, and we're going to call this, of all things, regression. All right, let me bring you back here a little bit. And so for this regression spreadsheet here, we're going to be analyzing not just one column of data, but two columns of data. So just like with your original descriptive stats sheet here, we're going to have a couple of columns on the left-hand side here for putting in some data, but it's not just one column, it's actually two columns this time. So we're going to select the first two columns and color those green. And just like before, we're going to have a little message in here, paste data less than dash dash for an arrow there in these columns. And let's just put in an ordered pair here, x, comma, y, indicating that our x values should be in the left column and our y values should be in the right column here. Once we've done that, it's now in column D that we're going to put in our title here, which is regression. And just like all of our titles, we can make that boldface and 18-point font. Skip a row as we go down here a little bit. This is going to be analysis. And we're going to be calculating a bunch of things here. Let me actually move to the right so that we'll be able to give titles to all of these things. Correlation coefficient is 1. Make sure you spell that correctly. R squared is another parameter. Sample size. T statistic. P-value. Slope. And intercept. All right, so those are the things we're going to be, the statistics that we're going to be finding from the two columns of data that we paste in here. And you know what, let's actually put in some example data here. I'm just going to put 1, 2, 3 in the first column for our x's, and then maybe 4, 5, 6 for our b values in here. You know what, let's make it so that it's not 6, it's 5.9. It's close. There's a little bit of error to all of this. It's not exactly clear what what it should be as far as the slope is concerned here. So let's select these two columns here, and let's actually create our chart. Okay, and that is definitely not the chart that we want to create here. We want to create a scatter plot. So as you can see here, this first point here is 1, 4. It's an ordered pair, 1, 4. This one here is 2, 5. This one here is 3, 6, or 5.9. So you can see they're pretty much in a nice straight line together here, so it will not be hard for this software to figure out what the slope and y-intercept is of this line here. So let's move this over to the right, and then for customization, let's just get the titles right here. For the horizontal axis, this is definitely X. For the vertical axis, this is Y. And for our chart title, it's the scatter plot. Okay, so very good. That is all set there. And then let's list how we would calculate all of these coefficients here. So for correlation coefficient, it's pretty quick and easy. It's equal to Correll, C-O-R-R-E-L-L, 2 R's, 2 L's, left parentheses, column B, so that's B colon B, just clicking on the column title there, comma, click on the A column here, so A colon A, right parentheses, hit enter. And that's being a little strange. I don't know why it's doing that. Should that be capitalized? Oh, just one L. That's what it was. So, Correll with only one L, column B, comma, column A. There we are. Okay, so very good. And we do not want to autofill this. All right, for R squared, that's nice and simple. That's just equal to this, in other words, the cell above it, squared. So that's this shift 6, which would be a little caret, 2. So the caret is how we show exponents here. So we're squaring what's above there. So d4 caret 2 is that squared. Okay, and that's our R squared value here. For the sample size, you can tell that the answer should be that we have 3 rows of data here, so that's what we want to get out of this. So that's going to be a count function here, so equals count, and we'll just select column A here, count up all of the number of values that we have in column A, and that's going to be used for the number of rows of data that we have. And you can see it comes up with 3 there, as it should. Okay, so for our T statistic, this is a little bit involved, this formula here. It's going to be equal to D4, that's our correlation coefficient, times the square root, SQRT, of a bunch of stuff. So I have a left parentheses here, and I'm going to type a second left parentheses here. And I'm going to say sample size minus 2, so D6 minus 2, right parentheses, division sign, left parentheses, 1 minus this R squared value here. And that's going to be a right parentheses and another right parentheses. Okay, and we should have a value there of about 32.9 as we're doing this here, indicating that we have very strong indication here that these things are definitely in a line together, and that we can definitely draw a straight line through this. All right, so below here we're going to be actually getting a standard p-value out of this T statistic here. So this will be 1 minus T-dist of this T statistic here, comma, sample size minus 2, and true. Okay, so T-dist D7, comma, D6 minus 2, comma, true. Okay, so there we are. Then there's 2 more. This is where we actually calculate the slope of the line that would go through those data points here. So, of all things, the command for that is slope, and the parameters are column B, comma, column A. And this should be pretty close to 1 that we get here when we do this. Yeah, 0.95, that makes sense here, since all these things are just edging up by a value of 1. So the slope is pretty close to 1. Then lastly, the intercept here, and that should be pretty close to 3 when we calculate this here. This is equal to, well, intercept, column B, comma, column A. And there it is. It's very, very close to 3, which shows that if we were to extend this line here so that it crosses the y-axis, it should intersect it at about a value of 3 here. It would be really, really nice if we could make it so that this shows the line as it's going through those data points there, but I haven't figured out a way to do that without adding a gazillion extra commands into this thing. That's actually it for this one here. I told you it was going to be short for this one here, so it's not a whole lot. I actually do have a little bit of data here that I thought would be interesting to put into this. For each of all these countries in here, I've plotted out, I've calculated what the electricity exports are and what the electricity imports are. And so I'm wondering if there's a positive correlation between those things or a negative correlation between those things. And so what I've done is I'm grabbing those two columns of data, and then I'm going to paste them, just values, into these two columns here, and I'm going to see what we get. Ooh, that's kind of interesting. There. We definitely have a strong correlation here. Correlation coefficient is very, very positive. It's a little bit messy here, but a very, very strong correlation, and it's positive. So I kind of thought that there would be reason perhaps for there to be a positive correlation here in that if you are making more energy as a country, that means that you have very, very strong demand for energy, which means you'd also be wanting to import energy from other countries. But there's also a reason why you might say that there's a negative correlation. Perhaps if you're generating more electricity yourself, then you have less need to import energy from other countries there. So there was a reason to think either way as far as those two values were. As it turns out, when we put this in here, we discover that the first hypothesis is true, that as you're generating your own electricity, you also are importing more, as it turns out, as a country. And so that's usually reflective of the fact that when you're generating more, it's because that you have overall more demand inside of your country, and you're just growing that way. So 217 data points here gives us kind of an interesting, albeit a little bit widely scattered correlation between these two things here. Okay, that's it. We are done with Project 5A. If you finish this up, let me have a look at it and give you points on this. And so this is going to be helping you for your last project, Project 5B, in which you're going to be having to do kind of an analysis very, very similar to what I just did here and write up what you get as a result. So I've enjoyed walking you through this process here, and I trust that this is going to be a very good set of tools for you to do statistical analyses, not only in your other classes here at ECA or Ames, but also as you move on through life.